Go. So this should be page 60 of our notes. All right, so what would the essential question here is an absolute value quantity is non-negative, okay? Since opposites have the same absolute value, an absolute value equation can have two solutions. That's the main thing here, is that an absolute value equation can have two possible solutions. All right, so at the top of your page, you have these key concepts. Starting off with the definition, the absolute value of a real number x written with bars, x is its distance from zero on the number line. Because it's the distance from zero, distance is always positive. It's always positive, okay? So for example, if I ask for the absolute value of 4, I'm asking how far is 4 from 0? And we would put 4. If I'm asking for the absolute value of -4, I'm asking how far is -4 from 0? And it's 4 units, okay? Just because you're walking backwards doesn't mean you're a negative distance. It means you're just a fool walking backwards, okay? Now, in terms of variables, absolute value and their symbols, the absolute value bars look just like the determinant bars of matrices, except instead of elements on the inside, there's only a singular number on the inside, okay? Notice here that if I have the absolute value of anything of an x, it's always x is going to be greater than or equal to 0. And then if you have absolute value of x and it equals -x, that's if x is less than 0. The absolute value equation simply is saying that you have an absolute value equal to a. With the absolute value equation, that means it splits into two possible problems. It splits into x equals a positive a and x equals a negative a. And the reason for that is if you look at the graph in our solution, there are two values that are the same distance from 0. And that's why it can be one or the other. Okay. All right, so we're going to get into the steps. So the steps to solve absolute value equations are as following. First, you want to isolate your absolute value. So you want to make sure that your absolute value is by itself. So absolute value on one side, all other numbers on the other side. You want to then remove the absolute value and create two separate problems, okay? You're going to have one with a positive solution and one with a negative solution. And then you're going to use your inverse operation. So instead of PEMDAS, we're going to use SAD method. So we go backwards to get the variable by itself. And then we're going to check our solution. Right now, we're not really checking for extraneous. You only check for extraneous is when you have two variables on both sides. But you're going to do that on Friday. So might as well leave the steps in here. So this is what we're going to do. We're going to isolate, remove, inverse, check. Isolate, remove, inverse, check. Okay. So 2 steps or less equations is where we're going to start. SAT, remember PEMDAS is where you parentheses, exponents, multiply, divide, add, subtract. When you are using inverse operations, you go backwards. So you're going to add or subtract first, multiply or divide, and then you work your way. All right, so here we have -6z equals 18, right? So step 1 says to make sure that it's isolated. Is there anything else on the side with the absolute value? No, so we're good, right? So step 1 is done. Step 2 is to remove the absolute value bars and create 2 equations. So the first equation is going to be 6z equals a positive solution. And the second equation is 6z equals a negative solution. And then third is to solve. So what do I need to do to get z by itself? Well, the inverse of multiplying is to what? Divide. So I'm going to divide everything by, that's not a 6. Oops. I wrote the answer, not the thing. Divide by 6, and that gives me z equals positive 3. Divide by 6. z equals -3. So my two solutions are z equals +3 and z equals -3 on a number line. That's because if I have 0, -3 and +3 are the same distance from 0. Does that make sense? That's why they both are possible answers. Step 4 is to check. So if I was to go back in, plug this in, absolute value of -6 times 3 equals 18, right? Absolute value of -6 times -3 equals 18. So I know I did it correct. All right. Think of absolute values like a number is going to jail. And whether it was negative or positive, why it went to jail, hopefully it'll come out a better person with a positive outlook. Was that terrible? All right, let's try another one. We're going to bring it up a step. Okay, so again, step 1 is to make sure your absolute value is by itself. Is there anything on the side of the absolute value? Good to go. Step 2 is to create your two equations, one with a positive solution and one with a negative solution. So I remove the bars and I have x plus 4 equals +11 and x plus 4 equals -11. Step 3 is to isolate the x. So what do I need to do to get x by itself? Subtract. I'm going to subtract 4 from everything, right? So these are going to cancel out. And I'm left with x equals, and 11 minus 4 is 7. Now over here, these cancel out, and I'm left with x equals, what's -11 minus 4? -15. So my two answers are x equals 7 and x equals -15. All right, how do we feel? So 4 is where we check ourselves. So if I plug in 7 plus 4, the absolute value of that equals 11. Check it out. If I substituted -15 plus 4, that equals -11, and the absolute value of -11 is +11. So that also checks out. So what this means on a number line is that if I'm at 4 and I go where? From -15. So I have -15 over here. That's not a -15. That was about to be 115. I have -15 over here, and I have +7. Ooh, this is not drawing the scale at all. It's saying that they are going to be my two solutions if you were to graph it on a number line. That's literally all you're doing on a number line, is where do they lie? Boom, boom, boom. And we all know how to plot points on a number line, right? Hopefully. Let's see. All right. I would like for you to try this one. So what this one's going to do is it's combining division and or adding and subtracting to get the k by itself. So I'm gonna pause, I'm gonna let you try, and then we're gonna check. All right, let's check ourselves. So step one, it's already isolated, so we're good to go. Bam. Step two is to remove the parentheses, move your absolute value bar. So we have 3K minus 2 equals positive 7. And we have 3K minus 2 equals negative 7. Are we still doing good so far? Step three is to solve for the variable. So to solve for this variable, like any other linear situation, we're going to have to add or subtract, then divide, right? So I have negative 2. So to get it by itself, I'm going to add 2. And I'm left with 3K equals 9. Opposite of multiplication is division, divide. So we divided by 3. And your first K value should equal 3. How do we do? Okay. Your second K value, we're going to, again, follow the same inverse operations. We're going to add 2 to both sides. We get 3K equals. And we get negative 5. We divide by 3. Does 3 evenly go into 5? Nope. So we leave it as a fraction. K equals negative 5 thirds. And you can always plug in and check. So if you're not sure if you did it right and you're not really comfortable or feel good about your math skills, you always have the calculator and you can go to your calculator. I'm going to plug in for absolute value bars. You either can go right here, the same place we get our matrix from. You can see the absolute value bar, or you can type in the word ABS and it'll do the same thing. So I have 3 times 3 minus 2. And I get 7. That worked. And then I'm going to do the fraction. And my fraction was negative 5 thirds. So I'm going to delete this. I'm going to put in parentheses, negative 5 thirds. Hit enter. And do I also get 7? Yes. So what does that let me know? That I did it correct. So is there any reason why I should get these wrong if I can check myself? Not at all. All right. Step number 4. So notice here now, is the absolute value by itself? No. So step 1, I actually have to get the absolute value by itself. Instead of multiplying by negative 2, what do I need to do? Divide. So I'm going to divide both sides by negative 2. So when I divide both sides by negative 2, that leaves me with the absolute value of y plus 5 equals, and what's negative 10 divided by negative 2? Positive 5. Perfect. A negative divided by negative is a positive. Now, am I good to go? Yes, my absolute value is by itself, and my solution is on the other side. So now, this is going to split into 2 problems, right? I have y plus 5 equals positive 5, and I have y plus 5 equals negative 5. Step 3 is to use inverse operations. So what do I need to do to get y by itself? Subtract. The opposite of adding 5 is to subtract 5. So my first solution is, what's 5 minus 5? 0. There's my first solution. I'm going to do it, repeat the inverse operations here. Minus 5, minus 5. And what's negative 5 minus 5? Negative 10. You owe me $10. So my 2 solutions are y equals 0 and y equals negative 10. How do we feel? Okay? Cool. All right, we're going to take it up a notch. So instead of 2-step problems, we're going to do multi-step problems. So flip it over. We're going to start big. but we're going to introduce the calculator here a little more. So for these, we're going to change it up. So the first thing we're going to do is get the absolute value by itself. So we're going to isolate our absolute value. So we have 1/2 absolute value of 3 minus W plus 6 equals 9. When we talk about isolating the absolute value, we want to get this guy by itself. So I need to move the 6 and I need to move the 1/2. What's the opposite of adding 6? Subtracting 6. So I'm going to subtract 6 from both sides. Does that make sense? So I'm subtracting 6. That leaves me with 1/2 absolute value of 3 minus W equals 3. What's the opposite of halving something? What's the opposite of halving something? And how, by how much though? The opposite of halving it is to double it, right? So instead of me cutting it in half, I'm going to double what you have. So the opposite of half is to multiply by 2. That's its inverse operation. So what I do to one side, I'm going to do to the other. And that leaves me with the absolute value of 3 minus W equals 6. Is it now isolated? Yes. Awesome. Since you did all of this work, now we're just going to learn how to do it in the calculator. So step 2 is we're going to actually grab our graphing calculator. So on our graphing calculator, we're going to go home and we actually want a graph page. So I like to start a new document. No, she doesn't want to be saved. I'm going to add a graph page. I'm going to add a graph page. Once there, I'm going to put in the left side is my F1. The right side is my F2. So in my left side, I'm putting in the absolute value of 3 minus W. Again, to get your absolute value, it's the button next to 9, and you should see it. There's my absolute value. But instead of W, what do I put in the calculator? X. So it should be absolute value of 3 minus X. I'm going to arrow down, and it's going to give me an F2. So again, I was at F1. I arrowed down. It gave me an F2. And F2, I'm going to put what does it equal? And what does it equal? 6. And then I hit enter. Where they intersect is my solution. So you see how where they intersect? For the calculator to tell me that value, I go to menu, analyze, intersection. So again, for the calculator to tell me that value, I go to menu. How do you zoom in? What do you mean? How did I move my graph? To move your graph, you see this button in the middle of your screen. You hold it down and then you drag it like a mouse and you can move your graph. I call it the dear life grab because it looks like it's holding on to his whole life. All right, so again, menu, analyze, intersection. And as you see how it says lower bound, how do you read a book? We read a book from left to right, correct? Same thing you do with a graph. You're gonna hold down and as you're gonna click and then scan from left to right. And as you scan, it'll tell you your intersection. So I have an intersection at -3. Do we see that? I'm gonna keep scanning. And I have another intersection at something I can't see. 9. So my two solutions are -3 and 9. And that is how it's done in the calculator. We'll practice it again. So we have W equals -3 and W equals 9. But in order to do it in the calculator, you have to isolate the absolute value, okay? So step 1 has to take place in order for you to do step 2. Ready to try it again? From the top. Yay, nay? All right, let's do example 6. In order to get to the calculator, we have to get the absolute value by itself. So step 1, what is the first thing I need to do here to get the absolute value by itself? Subtract 5, good job. And what I do to one side, I do to the other. So I subtract 5, and I'm left with 2 absolute value of 4x minus 1 equals, and 15 minus 5 is what? 15 minus 5 is 10. Good job. Okay. What's the opposite of multiplying by 2? Dividing by 2. And what I do to one side, I do to the other side. So I'm left with the absolute value of 4x minus 1 equals what? 5. Now, can I put it in the calculator? So step 2 is to graph. So I'm going to go to my calculator. Remember, Miss Jones doesn't like a lot of stuff on her computer. So I'm going to start a new document. No, I don't want to be saved. Instead of adding a calculator page, I'm adding a graph. I'm going to put the left side in first. So absolute value, clicking my math function, absolute value of 4x minus 1. I put that in first. I'm going to arrow down. And what does it equal? 5. So we put in the left side first, the right side second, and we hit enter. And our solution is where they do what? Where they intersect. So how do I get to the intersect? Anyone remember? So we menu, analyze, intersection. And we read books from where? Left to right. So we click on the left and we scroll. And where's our first answer? -1. And we scroll. And where's our second one? Uh-oh. Let me move my graph down. So I got the -1. And you can do it as many times if you want it to stay on the screen. So there's my -1. I'm going to repeat it again. I'm going to start from the left, highlight. Yes. The red line is your arrow down and you put in the value. So we had F1 was our absolute value. And then we arrowed down. And F2 was what does it equal? You see it? Thank you for asking. All right, so do we see our two solutions? So our answer is x equals, what's the first x value? -1. What's our second x value? 1.5. Okay, if you're taking multiple choice and 1.5 is not written as a decimal, remember you always can turn a decimal into a fraction. So if I have 1.5 and I want to know what it is as a fraction, I would go to menu, number, and it'll give me approximate a fraction. And the fraction is 3/2. So you always can change a decimal into an approximated fraction. So it's the same thing as x equals 3/2. All right. You can, but I'm saying if it's multiple choice and it has it, I just want to make sure you're comfortable putting it back. I'm fine with the decimal, but I'm just making sure you're okay. All right. All right. Last piece is always a word problem, right? We got to make it real world. So here's our problem. The amount of pretzels a snack food company fills each bag with must be within 3 pretzels of 100 pretzels. Okay. Expected per bag. A quality control inspector must ensure the bags are adequately filled. Let P be the number of pretzels in each bag and create an equation and solve for I made a horrible typo. The number of pretzels. I don't know why I put an extra in there. Okay, so it says that in the bag, there needs to be, they want ideally 100 pretzels. Have you ever got a bag of chips? You're like, ooh, they gypped me on some chips, right? Yeah, that happens often. So if we have a number line here, and our goal is to have at least 100 pretzels. So we want 100 pretzels, but you can be within 3 pretzels. So somebody may get 97, somebody may get 103, but those are okay, right? Because they're within 100 of it. So when you're doing this, that means that you have the distance from here to here equals 3, correct? The distance from here to here equals 3. Keyword is distance. Distance equals 3. Distance equals 3. So that means we have an absolute value that equals 3. So whatever the number of pretzels is, the pretzels minus 100 has to equal 3. And that's all we're doing. So just creating a number line, explain what it means. And so either you're going to get an unfortunate bag with how many in it? 97. Or you're going to get a good, really good bag and you have 103 in it. But as long as you're within 3 of 100. All right, there are additional practices on your notes that I would like you to do. They're just extra practice for you. So if you still want to try a little more, isolate, ask me questions. Those are the questions you've asked me to help you with in tutorials, or if you can't do them on your own. But please try, because you can do it.